Let's take a look at this problem. Jeff recently drove to visit his parents who live 380 miles away. On his way there, his average speed was 9 miles per hour faster than on his way home. He ran into some bad weather. If Jeff spent a total of 19 hours driving, find the two rates. And let me get back there. Okay, so we're talking about home and the parents. And the problem says that he went there and then he returned home. Well, there's two types of distance problems we take a look at. The formula we're working with in both of them is distance is equal to r times t. And in one of them, they work together to achieve the distance along the same lines. And when I say they work together, that means your distance is equal to the rate and time of your first item plus your rate and time of the second item. Along those same lines, they're kind of working together but kind of working against each other. You subtract. This is like where one vehicle is following another vehicle and how on before they overtake each other. So you're subtracting these, and where the distance maybe is equal to 0 or something to that effect. Or where they say that they ask when it's 500 feet apart. But anyway, these are kind of the same types on those. And then the other type is where they're going the same distance, where this distance is equal to this distance, which is the type we're looking at. And that formula looks something like this. R1T1 is equal to R2T2. Okay. Now, before we get to that point, though, let's use a box to help this set this up. Now, go in this direction we're going, and this is where we're returning. Okay, so we're going, and we're returning. I'll put distance here. And then we have our rate and time. And there'll be a times here. In this problem, they say Jeff recently drove to visit his parents who live 380 miles away. So they're telling us that the distance from the home to the parents is 380 miles. Well, if you're going, whether you're going or coming back, it's still going to be the same. So this is 380. And this is where the equals is implied. I should have done that in a different color. That's your times. Okay, let's see what else it says. On his way there, his average speed was 9 miles per hour faster than on his way home. Okay, so returning, we'll say his rate was R. On his way there, his average speed was 9 miles per hour faster. Well, if this is R, 9 miles per hour faster, this would be R plus 9. And Jeff spent a total of 19 hours driving. Now you want to pick the line with the single R, and with it, we just put T there. Okay, now there's a total of 19 hours. Well, imagine this is 10 hours here. It's not, but imagine it's 10 hours. Then ask yourself, how many hours would this be? Well, it'd be 9. And how you get that is you do 19 minus 10, whatever you got here. Well, instead of this being 10, it's T. So this right here will be 19 minus T. Okay. And again, there's implied equals here, and a times there. So that's our table. Let's see what that gives us. For this this first one here, we got I'll go ahead and put these on the left side. We got R plus 9 times, write that a little bit neater, R plus 9 times 19 minus t is going to equal to 380. Now in this one, we got r times t is equal to 380. Okay. Well, the problem with this is we got two variables. So we got r and t. Different ways you could work this, but you definitely can't use solving systems equations based upon lines, because when you multiply this together, you're not going to end up with a linear pattern. It's not going to be like x plus y is equal to 3 is what I'm saying. Well, the easiest way, I believe, in this problem is you start with a simpler equation and solve it for one of the variables. We're going to use substitution. Okay, so I'm going to solve for r, I guess. So in this case, I divide both sides by t. And we get r is equal to 380 over t. Okay, well, if I come over here, I'm now going to substitute this into the other equation. We now know what r is. It's 380t plus 9. This is 19 minus t is equal to 380. Well, let's see. We have get rid of these parentheses first. So I'm going to take 380t and multiply it times 19 and multiply it times negative t. And then I'll take 9 times 19 and 9 times negative t. So we've got 380 over t times 19 and 380 over t times negative t. And then we got 9 times 19. 9 times negative t equals 380. 380 times 19. 380 times 19. 7,220 over t. Here the t's would cancel and leave us minus 380. 171. Let's see, 81, put the 1, carry the 8. Yeah, 171 minus 9t equals 380. And we've got 720 or 7,220 over t. And then let's combine those numbers together. So we got negative 380 plus 171 gives us negative 209 minus 9t equals 380. Now I'm going to go ahead and bring that 380 over. So we got 7,220 over t minus 209 minus 380 minus 9t is equal to 0. And I'd probably do that one. Still a little sleepy this morning. Let's see, 9, 8, 589 minus 9t is equal to 0. Well, this is a rational equation at this point. We got a variable and the exponent, so we just want to get rid of that variable and exponent. So we'll multiply everything by t. So we'll take t times 7,220 over t. And we'll take t times negative 589 we'll take t times negative 9t and t times 0. Those t's cancel, so we got 7,220 minus 589t minus 9t squared equals 0. Well, this is a quadratic at this point, so I want to get everything on one side, which it is, but I want to get rid of some of these negatives, so I'm going to take them all to the right side. So we're going to have 9t squared plus 589t minus 7,220. Now I'm going to use quadratic formula on this. It's probably going to be the easiest way. So I got a is 9, whatever's in front of you, t squared. B is 589, whatever's in front of you, t. And c is your negative 7,220. And we got t is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So we got negative 589 plus or minus square root of 589 squared minus 4 times a times c all over 2a. So we got negative 589 plus or minus square root of 589 squared and we got a negative times positive times a negative, which ends up giving me a plus. 4 times 9 times 7,220. $606,841. Over 2 times 9, which is 18. Now the minus doesn't make any sense because that ended up giving us a negative. So we'll work with just the positive. So I'm going to have a beginning parentheses, negative 589 plus the square root of 606,841, closing parentheses on the square root, closing parentheses on the top part, divided by 18. Enter. And gives us 10.55. Bunch of fives forever, looks like. Let's see what the problem says. If Jeff spent a total of 19 hours driving, find two rates. Okay, so we just found t. And I could change that to a fraction on my calculator, since it is like that. So I'll do math, enter. And we'll get 95 over 9. Why did I change that to a fraction? I saw that they weren't looking for the time. Okay, so I come back up here, and here's my two formulas. So to find what r is, I can now plug it in at this point right here. R is equal to 380 over t. So r is 380 over t. So I'll put 95 over 9 there. Now if you got a single fraction in the denominator, you can flip it, take a reciprocal of it, and multiply times your top. So we've got 380 times 9 over 95. So we've got 380 divided by 95. And that tells us that the rate is 36. Well, you got 36 miles per hour. I'm assuming miles per hour. And the other one is r plus 9, so it's 9 greater. So if that's 36, then 9 greater, 36 plus 9 is going to give us 45 miles per hour. And those will be our two rates. Now that's just one method of solving that particular problem. There's other methods, different ways you can do substitution and so forth. Probably even different ways you could set this up. But